Hi, do you hear me? Hi, everyone. Thank you for coming. I'm really glad that you're here. So I have a short disclaimer. Yesterday, my laptop was grabbed by someone. Maybe my presentation is too important for someone, so he decided that it's better for him to have this. So I set up quickly everything on my personal laptop, but if something is going wrong, just don't accuse me as much, because I try to do my best. Just to start, I want to ask you, please raise your hands if you're already familiar with Kotlin. Oh, pretty much. And with gRPC? Just a lot. Usually in other conferences, there are less people who are familiar with this, so I can tell some bullshit. But now I think that you can just answer my questions or just say that I'm wrong sometimes, but after my session. So let me introduce myself. My name is Marharyta. I am a software engineer at Wix.com. I think that you've seen our stand and our interesting confession corner. So I am a software engineer here. There are several speakers from our company here, so you can talk to us and to discover our technologies. I am also an active community member here in Kyiv. Something is wrong with my presentation? Oh, it's okay. So I'm also an active community member, and I organize some different meetups, conferences, because I'm really passionate with knowledge sharing. So you can contact me if you want to ask me something and some topics. I also post something on Medium, so you can tweet and talk to me. One more really important thing that you should know about me is I really enjoy boxing. So think twice before asking me tricky questions. Of course, I'm kidding. So agenda. Today we'll talk about why gRPC, why should we have a look into it, and why we should consider gRPC. Then we'll talk about proto buff, its ideal used in Kotlin. We'll implement some simple service. We'll learn how to write interceptors, how to do error handling, a short introduction in testing, and then we'll discover more specific lips for Kotlin. Let's start from the very beginning. In the very beginning, it was a huge monolith. And after that, it exploded in a lot of microservices. So now I have a question. Raise your hands if you're writing microservices today. A lot of people are writing microservices today, or at least think that they're doing so. Why? Why are we loving microservices so much? Because microservices rock. They're independent, scalable. You can mix different technologies. You can write some service in Node, some service in Scala, some in Java, and it works. It's like a magic. And of course, you can do parallel development because you define some contract, and one group of people was working on one microservices, and other people working on other microservices, and everything is fine, it works, and everyone is happy. And we can talk about pros of microservices very much and very a lot, but there is always one but, one big but. So the biggest issue in changing a monolith into microservices lies in changing the communication pattern. So the biggest problem is communication. Why is it so? When we worked with a monolith, we just can trigger different services, we can trigger different classes, call methods, and we do it directly. And we rely on it. When we're using microservices, you cannot rely on it anymore. You're using some communication channel. It could be some protocol, some HTTP, TCP, some other stuff. You can use Kafka. And now it's something that is not reliable in general. So you can change something in your mind. By the way, do you know who said this? This is not my words. This is actually a quote. I have some prizes. If your answers are right, I can give you this prize. So be active during my session. Yeah, he was the first. So what do you want? Purple. This is for you. Thank you. Really? This is Martin Fowler. So one more question. I guess you're not tired to raise your hands, so I would like to ask you to do this one more time. Raise your hand if you're using HTTP1 and REST today. Almost everyone who are using microservices use HTTP1 and REST today because it's common practice. Actually, in Wix, we also use it. We use a lot of different technologies, and this stuff is also one among them. But it actually works. It's OK for everyone, and actually, why should we do something else? But sometimes you might face a situation when you have a lot of different clients, and you're growing and growing, and you need to have more and more servers, and you pay a lot to Amazon, to Google Cloud, to Azure, and you spend more and more money, and it costs you much money. So what is the question? Maybe there is a way, only by changing the communication, to reduce these costs. Just by doing efficient communication to reduce it, to pay less, to have less servers, but to be still efficient, and maybe to pay more to developers. I would be happy to if I have more money than Amazon and Google. So maybe we can do this. So gRPC can somehow solve this problem. I'm not telling that gRPC is a silver bullet, but it can help you. Why? Why gRPC is so cool? First of all, because gRPC uses HTTP2. I think maybe some of you heard about HTTP2, but most of you probably is using HTTP1 today. But why HTTP2 is so important? We won't have really we have only a brief overview of HTTP, but let's look into this protocol evolution. As you can see, in 91 it was 0.9, then it was 96, 97, pretty good growth, and then no progress, no progress, and no progress, and still no progress, and still no progress, and suddenly, in 2015, a new version of HTTP2 actually appeared. Are you kidding? Everything changed. The whole internet changed, and only that HTTP2 appeared. Actually, to have like a brief overview maybe of my life, I started going to school. I graduated from school. I started going to university. I graduated from my university. And only after that, HTTP2 appeared. So I guess they had a lot of things to think about, and they have a lot of things to do. So HTTP has some crucial improvements. What are they? First of all, they're using single HTTP connection. Before this, we had one TCP connection per request, and each request, we opened new connection. For now, we are reusing this connection per client, and it's pretty smart, because it saves your time in order not to open new connection, just reuse one existing one. Then you can do bidirectional streaming, because if your connection is always open, you can use your client to stream to server, you can use your server to stream to client. So it's bidirectional streaming by default, and you do not need WebSockets anymore. It's pretty good. You should clap on it, like it. Then HTTP2 introduces flow control. What is flow control? As you can see, sometimes, maybe all the time, your server and your client cannot handle all the requests we're sending to each other because of different capabilities. And there should be some flow to control this, to buffer some requests in order not to make your server down. Because if your server is down, your clients are angry, you can lose your clients, you can lose money, and it's not really a good situation because I don't want to lose my clients and to lose money. So flow control is cool. So that's enough about HTTP2. If you want to look more, you can read about it. We are not much into HTTP2. Let's talk about gRPC. gRPC also supports a lot of languages. So you can write your microservices in Node, in Ruby, in Python, and they can work together using gRPC. And gRPC is binary protocol. First of all, it's binary because HTTP2 is binary protocol. HTTP1 is text protocol. And HTTP2 is binary, so you can say bytes. And if you know, bytes are cheaper than strings. I guess I don't need to prove it. So if you use bytes, it's cheaper. And we are using protobuf. Protobuf is ideal used in gRPC, and it's also binary. So you send binary data, and so you save your time and save your space. And that's why gRPC is more efficient than HTTP1 and REST together. So I guess you'll get a little bored because I'm talking too much. I have one more riddle for prize. What does gRPC stand for? Yeah, actually, first of all, I heard that it's gRPC remote procedure call, but it's not true anymore, because for each version, they have a different meaning of RPC. So who was? It's for Geo. Who said this? Who said this first? Okay, what do you want? Okay, this is yours. So yes, I don't know why they did it, but each version of gRPC, they have a new meaning for the first letter. And just like a funny story, it doesn't have a sense for my presentation, but it's funny. So, how is Wix connected to gRPC? Because I'm talking a lot about gRPC, some stuff, HTTP2, but let's return to land. Our conference is devoted to space, but let's return to land and talk about company working. In Wix, we like gRPC very much. We try to introduce it everywhere. Actually, we had a talk about it today, how do we move to some asynchronous RPC stack. I won't talk a lot about it. I just tell you that in Wix, we are using gRPC. And in order to make this done, we have Scala plus Scala PB. In Wix, we have a lot of Scala. And unfortunately, Scala hasn't native support in gRPC. But there is a cool library called Scala PB, which built a lot of stuff upon this upon gRPC Java, and we can benefit from using Scala and gRPC and be really happy with it. And actually, we can stop my presentation at this point, but it's not so easy, because there is a group of people who like Kotlin in our company. There are a group of people who want to introduce Kotlin like one more language who write in microservices, because I'm really happy to have a choice. Not just to use like one language, I want to have a choice to use language I want. It could be Scala, Java, Kotlin, Node, Go, Python. So I'm really happy to have multiple choices, and that's why I want to introduce Kotlin. And we started to think, is it possible to introduce Kotlin with gRPC into our technology stack? This is not in production still, yet, and we are working on it. But I hope someday I should go have a session, and I'll tell you that now it's in production and Wix uses Kotlin. For now, I can't say it, but we're having it in some sandbox. We're working on it, and Wix actually likes Kotlin. So let's proceed with the second topic. It's protocol buffers. What is it? Protobuf is ideal used in gRPC. According to Google, it's some platform language natural extensible mechanism for structured data. So it's like XML or JSON, but simpler, faster, and smaller. So look at it like XML, but simpler, faster, smaller. I guess there are a lot of words here. If you want to have like more time to learn it, you can go for this link. But let's look how it looks. In order to use protobuf, you need to define some proto file. This proto file looks like this, so it looks like code. And in this code, you have your service, for example, greeter, and you define your RPC call. In this RPC call, we have like request and response. And after that, we define what request and response is. Hello request is just name, and hello reply is just message. So it's pretty clear, and how it works under the hood. So we have protobuf, then it's compiling. And it's compiling to different languages. So you have this proto file defined, and when you compiled it, you have these entities in the language you chose. And you can use it. You can use it in your servers and in your client. That's why if you compile it to different languages, you can communicate between different languages. So let's summarize what protobuf is. If you want to have like further overview, you can go to protobuf.io and learn about it more. But let's summarize. Protobuf is type safe because it's compiled to the language you are using, and it's actually the entity in the language you are using. And if you have some problems, you'll see it. You cannot violate the schema because methods are also compiled into method of your language you're using. And that's why if you pass something wrong in Java, Scala, or Kotlin, you have compile time errors. In JavaScript, you have runtime errors, but you'll have these errors. Serialization and deserialization is fast. Because when you pass these messages between server and client, they're compiled to binary. So it's just array of bytes. and array of bytes are cheap. And backward compatibility. As you can see, gRPC uses protobuf, and we use the third version of protobuf. In this version, all fields are optional, and as far as they are optional, you can simply introduce new fields, and you can duplicate all fields. And it's pretty easy. But the main disadvantage of protobuf is human readability. Because actually, if you have only message, it's just an array of bytes. Without having proto file, you have no idea what it is. So if you need human readability, maybe protobuf is not what you need. It's enough talking. Let's implement some simple service. This conference is dedicated to space. And as far as we're dedicated to space, and I'm a huge fan of Star Wars, let's build a Death Star. So this tiny Death Star. What do I mean? Task for this session. First of all, we write a service to destroy planets. Actually, now we can destroy planets. Guess you understand how huge it is. Then we can destroy as much planet as you want and tweet. Actually, it's like just for fun. It's not obligatory. And after the session, the person who destroyed as many planets, the most number of planets that get the most score, will have a prize from Wix. I have this back. It's not empty. And enjoy the session. I hope you enjoyed. So application is in production here. So if you are bored with my session, you can play with it and destroy planets. You'll find out that it's not that easy to destroy planets because the more planet costs, the more difficult it is to destroy it. You need to click more times. So you can take photos and maybe. So can I skip this slide? Go to next slide. OK. So for those who don't want to play but want to learn something new, let's discuss. In order to understand what we should implement, I made two diagrams, two activity diagrams. What it is? When user joins our service, it goes to like the star and say that I'm joining. Then the star goes to planet service, and gets all planets we are having alive here. After that, planets are returned to Death Star, and Death Star returns planets to like client. And one more disclaimer for those who are playing: I'm a server developer. That's why you see what happens when server developer does UI. So sorry for this poor UI. I am not like very good at it. So after a user has planets, we go to log service in order to log actions. And then we go to score service in order to like to subscribe to scores. And you can see that logs return some information from log service, and scores also return the whole table of scores, and you can see scores like at your screen. And the second action is destroying planet. When user wants to destroy planet, we go to Death Star, and we are saying that I want to destroy planet. And we go to planet service, and we delete one planet. When planet is deleted, the result is returned to the star, existing planets and new planets are generated, and then we log every action, and we add new score. And after that, we notify client about logs, about scores, and about existing planets. So it's pretty easy. It's not the best architecture ever written, but it works. So let's proceed. Let's actually implement it. This is the time I'm afraid most of all, because it's not my laptop that I'm working all the time, and something may went wrong. Let's start. Do you see code, or I need to do it bigger or less? Okay. So you can see that we have the star service implementation. In order to implement this, we need to implement the star service simple base. And let's implement this actual method. In order to do this, I am a little bit cheater. So I have templates, and we see. In order to implement this service, we are using stream observers. Why? Because Java does it. So what are we doing? We add our observer to response observers in order to have like subscription. Then we get all planets and return. So you can see that destroy method is bidirectional streaming. So response observer observes and client can observe to subscribe to our stream, and we also return in stream. You can see that this code is really big. And raise your hands if you like it. You're crazy, because I don't like it too. Why is it so? The problem is that everywhere you use just new stub, but in gRPC we can use different types of stubs. Let's try something else. Why I so hate like simple stubs? Because when you're doing simple stubs, you need to pass callback. And in Kotlin, it looks this way. You need to like implement. And I wrote less code because I implemented delegate. This delegate. If you're familiar with Kotlin, you understand what it means. But if I have no delegate, all this code is duplicated in this, and this. Every time you see by, this code should be duplicated there. So it's pretty much. And like passing callbacks is like old-fashioned, and it's not really what we want to do in Kotlin. So let's do something else. We can do future stop. Let's use future stop everywhere. So it won't compile, actually, it's OK, because let's delete this. Yeah. So now you can see that we return future, and it's less code. We do not need to pass any callbacks. So now when we are calling some methods from other services, we can do await, and we having asynchronous code which is written synchronously. But to have like server and client streaming, we still need to do stream observers. And actually, this is not the stuff I want to do in Kotlin. Why is it so? Let's return to our presentation. Because what we did is actually Java code written in Kotlin. But who we are? We're Kotlin developers. No, we want to be Kotlin developers. And we don't want to deal with stream observers. We want to deal with channels. We want to work with coroutines. I think you understand what I mean. Because if you work with channels, you do not need these ugly callbacks. You just work with channel. You can send and you can receive, and it looks like synchronous code, which is written, which works synchronously. So maybe we can do this. So yes, there is a way to do this. First of all, we need to go to our API and change a little. We need to have one more plugin, it's gRPC Kotlin. We need to import it. And let's build. And let's return to our desktop implementation. Oh, no, that's not what I want to do. Let's try gRPC Kotlin. And I guess we can do this way. So, and let's refresh. You can see that it doesn't compile because we're using another module and we recompile that, but we need to refresh all dependencies here. I guess it should compile. What's wrong with it? Okay, I know what to do. We can do a hack. Sorry, that's what I meant, that I have not my laptop. I don't have my laptop, and something may went wrong. Something is going wrong. Actually, it doesn't compile because we have another version of the library. So maybe you have an idea why it doesn't compile. So I had a lot of hands who, oh yeah, it works. So the problem was with refreshing Gradle and with ugly internet. So you can see that now we are using coroutines. And you don't see any stream observers and any callbacks here. So what are we doing? We have channel, and we add channel to our listeners. Then we launch coroutine, and we send our messages to the channel, and we receive it. And it looks like synchronous code. But according to that we are using channels, it's asynchronous. So everything works, and you don't see that ugly callbacks. It's the whole method we need to write. So do you like this code? Because I don't have any other variant. If you don't like this, you need to write it in your own. So you should like this one, or that's all. Maybe we can just let's run it and think that if it works or not. Okay, I'm not sure if we can still wait on it. I don't know why its laptop doesn't want to obey me, but it looks like it lives their own life. So you can see that it actually works, and we can put some name. We can enter, and we'll see that it doesn't work. Something is wrong. Okay, I guess you see that it works in production. Does it work in production? So I think I'll fix it next time. Yeah, I hope that it's problem. Yeah, it's a problem with the internet. It works. What's wrong with my presentation here? And that's what I'm really sorry, guys, but it's not my natural laptop, and I'm so sorry for this. So the problem that I told you, that we can have channels, but we still don't have deferred. So we need to deal with listenable futures. But if we contribute to that library, we'll have deferred in Kotlin. So first iteration is done. We'll take a look at single calls, in server streaming, in bidirectional streaming. We'll saw simple stuff like blocking stuff. Oh, I didn't tell you about blocking stuff. Sorry, it's the main stuff is future, but it doesn't return some listenable future. It returns you the value, but you need to block your thread. Actually, it doesn't have a sense in Kotlin, because in Kotlin you try not to block. You try to use unblocking stuff, and that's why. And I also showed you channel stuff, how to use channels. So one more topic is interceptors. What is it? Sometimes you don't want to do some stuff only in the service you're implementing. You need to do something before your service has this call, or when the service is on, when you want to return the result of your call. You can do it in interceptors, some stuff like login, like doing something else, and that's all. But let's hack the system. What I mean? If you can see now in production, if it works, you're destroying planet and you get some score. And when you get the score, it's written behind the planet. But what if I want some user to get 1 million score for any planet? Each time I destroy a planet, I want to have 1 million. Let's do this. So let's stop the server. And how can we do this? Let's go to hack the system interceptor. And I've already written it. So what do you use? I implemented client interceptor, and in that method, I hack the call I wanted to send, and I override method send message. What I'm doing? I'm getting that message, and if the username is Margot777, I set weight to 1 million. So it's pretty fair. Don't you agree? So if I have 1 million, and that's actually the thing you should implement. And after that, we're going to our desktop client. And we can see that when we are consuming, we are having the channel, and then we add interceptor in that channel. So we intercept our channel with that hack system interceptor, and only that we create new stub. So now our stub works with that interceptor, and okay, I shouldn't do this. It's the wrong solution. Just believe me that it works, because I don't want to run it. So believe me that it works. When I put the name of Margot777, I have 1 million when I destroy some planet. So let's summarize. To add interceptor, we need implement some server client interceptor, because actually we need this interceptor. Then we need to implement method intercept call. And we need to add this interceptor to server or client. So that's all. That's all about interceptors. Let's talk a little about error handling. What is error handling? All families are happy, or happy families are alike. All unhappy families are unhappy in their own way. Do you know whose words are these? Who said this? Who was the first? So you have no choice. Maybe someone else needed. Okay. Who was the second one who told Tolstoy? So let this be this guy. I don't want to bring this stuff home, because I have too much this at home. Yeah, you're right. This is Leo Tolstoy from Anna Karenina. I'm really mad at this internet connection here. So what does it mean? When you have success, when everything works, it just works. So it's status code okay, and everyone is happy. When you have some errors, you have some general errors, you can have some network failures, you can have some protocol errors or different types of errors. So when you have errors, you have different types of errors, and it's cool when you have different messages because you can understand where the problem is. But sometimes error is not only in connection in some protocol, sometimes error is in your business logic. So what about custom exceptions? Unfortunately, when your server returns some custom exception, you have status code unknown. So it's status code unknown, and you know nothing about it. But there is a solution. You can write an interceptor and actually check and return proto status code in the interceptor. And in client, you have not status unknown, but your needed status. And you can handle it somehow. So just, let me show you the code. So you can see the code that is the same interceptor, but now it's server side. You implement server interceptor, you implement intercept call, you wrap your call in some other stuff. And now we return status code internal, and we'll have some proper description, and we also have stack trace. For example, with some important exception, now in description we'll have the stack trace of it. And it's pretty useful. Sometimes it could be pretty useful. So that's enough with custom exceptions. Let's talk a little about testing. Do you write tests? Yeah, who writes tests? Raise your hands. I write my tests first. You are saint. Yeah. What I mean that after my session, you may not use gRPC, you may not use Kotlin, you may not bring anything from my presentation, but you can bring one thing. You should test, you should write tests. Because let's talk a little after my session. So if you don't write tests, because Darth Vader will come to you, and you saw in movies how it ends. So in order to unit testing, to do unit testing, we have in-process server builder and in-process channel builder. So what do I mean? We need to build a server, and we need to add some mocked service to it, and to do it in process. So if you saw in my code, we use some targets. So I mean, we need to have some host and port. But when you do it in process, it just acts in your laptop in process. And it looks like this. So we have a process server builder, and then a process channel builder. And after that, you can do the stuff with it. And do not forget to clean up and write tests. Actually, there is no, there is not some special to write in tests. That's why I have no example for it, because it's the same as for any other test. You just should use in-process server builder and process channel builder. But what about integration and end-to-end tests? Who are writing integration and end-to-end tests now? And what tests are you writing? Those who raise hands. So I just write in unit tests. What I want to say is that integration tests and end-to-end tests are important. And for now, you can do them very quickly, having some containers, so testing containers. That's why I write them. You may not use gRPC and Kotlin after my session, but you should start writing integration and end-to-end tests. It's just like my message to you. So, unfortunately, when I tried to find some information about how to write end-to-end tests and integration tests using gRPC, I find nothing. Just this message, just may the force be with you, and create something on your own. But in Wix, we have a solution. In Wix, we have a solution. We try to do our end-to-end and integration testing more have unified approach, and we try to introduce test kits everywhere. So what does it mean? A person who writes a Death Star writes stuff to test it. So we actually write some testing, like mocked services, mocked servers, and some matchers in order to help other people to integrate with you. So other services are integrating with you, and they're also using your libraries to test it. And it's okay. So let's summarize. Write unit tests, then deal with streaming easily. It means that actually you can deal easily with streaming using gRPC and this in-process channel and server builder. Unfortunately, there is no unified approach or lib for IT and end-to-end tests in Kotlin, but at Wix we use test kits, and you can also take it into consideration. By the way, in this conference we had a talk about test kits. If you were here, you know what I'm talking about, but after the Devoxx is ended, you also can see it in YouTube. So this is the most interesting part. Just it was like boring part, and this is interesting. What I expected when I started to consider Kotlin and gRPC. I thought that I have these cool robots. I have these robots who can save my life, who can rescue the planet and do whatever we want. Unfortunately, I found this. It's like these guys who cannot even shoot anyone in 8 episodes. But we have what we have. That's one of our presidents said. We have what we have. So we need to deal with it somehow. When I did kind of this presentation a few weeks ago, it was gRPC Kotlin. First of all, I thought that it's official version of library, and I was really happy. But then I found out that it's version 002. It's not really like the thing I want to rely on. And there is a warning that this project is kind of prototype, it's not in production, blah, 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 so you don't use it. It's like a disclaimer to declare some bullshit and to put this warning. And I was a little upset that I can't use it and try to find something else. But it was 5 weeks ago, you see. And now we have version 010. And we had a lot of, we got 3 contributors. I also started communicating with the guy who is implementing this. And for now, all this demo is written on this library. It's not really ideal. There are some drawbacks, there are problems, there are things that are not implemented yet, but we are working on it. And actually, you can contribute there. I'm here to ask you to contribute if you want to make it better, because I also have some ideas how to do it better. I contact this guy, and you can contact him as well. We also have a chat. I'll show you a little bit later. So I like it, and I hope you like it too. There is also another library called Proto Plus. It's something similar, but it's built on top of Kotlin Poet, and it's interesting library, but it's only for Gradle. So if you're using something else, you need to contribute, and you have pull requests with Maven plugins or Bazel plugins or whatever you want plugin. But it's pretty interesting. You can look into it. I have a more useful links. First of all, it's Salesforce repositories, gRPC Java contrib. You can contribute into gRPC Java. You can build something on top of this stuff. And actually, gRPC Kotlin is built on top of gRPC Java using this Salesforce generator. There is also reactive gRPC and gRPC also from Salesforce repository. And interesting stuff. You can also look into it and use it. And there is also protobuf and K. It's a cool protobuf library for Kotlin. We are now not using it in gRPC Kotlin, but maybe we'll use it for some multi-platform because we are still growing and we are using some stuff. And the last link is actually my repository. You can play with it and do some stuff if you want, clone, and maybe have some pull requests. One day, I hope we'll have perfect Kotlin support, as better as in Java. And we'll work with it. So time to summarize. I spoke a lot about gRPC, about Kotlin, about testing, so it's time to do some summary of this talk. Takeaways I want you to take. First of all, use gRPC for effective communication. gRPC actually can help you to be more efficient, to spend less money, to have less services, to be more effective. Then gRPC plus Kotlin can be used today. This is not ideal, but it's improving every time. So maybe next week we'll have one more release and it will be more better and better. So it's growing fast, and people who contribute there, they're really active in it. So we're still working on proper coroutine support, because as you know, coroutines were finally released. They're not at experimental status anymore, and we can use it. So I hope we have ideal support of coroutines in gRPC Kotlin. And feel free to contribute. You know that it's not ideal, but you have a chance to improve it. So that's my message to you. If you don't like something, just contribute and improve it. And as you know, it's Thanksgiving weekend. So it's time to say thank you. I want to say thank you, just to say thank you for several people who, without them, I wouldn't have done it. I wouldn't have done my presentation without several people. Who is it? First of all, it's Ray. because he inspired me a lot. I had a look into his presentation. He inspired me. I also talked a lot and on some conferences, and he also showed me some interesting repositories. And actually, after talking to him, I totally rewrite my talk. Then is this guy, is Rusvavi, is his nick, and he is the best contributor of gRPC Kotlin. Actually, he's an author of gRPC Kotlin, and I like this guy because he's really active in it, and he was really likes what he's doing. He's improving every time. There was a thing when I just downloaded the latest version, and while I was downloading that version, he just made a new one. It was scary because I don't understand why anything works, and documentation is not that, and they understood that I have not the latest one. It was a funny situation, but I see that he works on it and he is active in it. The third person I want to say thank you is Alex Borisov. He works at Google and he reviewed a little my presentation, and thank you a lot, because without him this presentation would be more ugly than it is. And this guy, I hope you know who it is. Who said it? So this is your present. I don't want to kill anyone. This is made from metal, so. Just thank you, because a lot of people don't know who is he. I was really upset today. So it's just look out. And of course, thank you very much for coming. Thank you for supporting me today. And yeah. And if someone was playing with my game, I hope it worked. So someone played with it. So let me. Oh, it's ugly internet. So, Alexander, who is it? Who is Alexander? Just go to me after the session and I'll give you a prize. What? Oh, who is Alexander? You can come to me. So let's talk after the session, and just what's wrong with this laptop? So it's time to questions and answers. That's all. Yeah.
Why do you like Kotlin? Why I mean, if you have, you can work with Scala. I mean.
Yeah. I know I work with Scala. I like Scala also, but the thing, there are some things I don't like about Scala is poor IDE support, and I think that it slows me down sometimes when it's not incompatible in compiling an IDE and in CMD. Sometimes it makes me mad. And actually, I started learning Kotlin, and I'm familiar with Kotlin more than with Scala, because I started learning Scala 10 months ago, and with Kotlin I'm more than a year. So I like both. I just like the ideology to have a chance, to have something to choose, to have more opportunities. So I'm not against Scala. I like Scala too.
Okay, maybe I'm the one who didn't understand, but what is gRPC?
It's a RPC framework from Google.
And what is an example of it?
What do you mean? It's a process of communication between microservices. When you're doing microservices, you need to communicate somehow. It might be Kafka or some HTTP, so you can do gRPC. gRPC, it's a framework built on top of HTTP too. So it's just for communication between microservices. It means you're just calling some method from other service, and you think that it's like your service, but it is somewhere else, maybe on the other server. So it's a little bit clear for you?
Yes, thanks.
Okay.
Understood. Who is next?
Okay, so thank you for coming. That's all.